Hello guys, welcome back. Today we are going to be discussing the law of cosine to solve oblique triangles. What are oblique triangles? Any triangle that is not a right triangle. So for the law of cosine, essentially, if A, B, and C represent the angle measures of an oblique triangle, and lowercase, oh, that's n, okay, and lowercase a, that's supposed to be a letter A here, guys, lowercase a, lowercase b, and c represents the sides of that triangle, then this means that we can use the following formulas, guys, to find any lengths of a side of a triangle. So we can use this formula to calculate the length of side A squared is equal to the sum of the other two sides squared, as in B squared plus C squared minus twice B times C, the lengths of B and C, multiplied by the cosine of the angle, in this case, angle A. Likewise, if we're looking for side B, we'll use the following formula. B squared is equal to the other two sides, the sum of the other two sides, squared minus twice the lengths of those two sides times the cosine of angle B. And then last but not least, if we are looking for the lengths of C, then we'd take the other two sides and square them, find the sum of the other two sides squared minus twice the lengths of these two sides multiplied by cosine of C. By the way, on a side note, you should notice the third formula here, C squared equals to A squared plus B squared minus 2 times A times B times cosine C, is very close to the Pythagorean theorem, except you've got this part in here. So if we were to go ahead, guys, and plug in, let's say, 90 degrees for C, okay, 90 degrees referring to what? A right triangle, so that wouldn't be an oblique triangle. Remember, we're talking about oblique triangles here. And cosine of 90 degrees, think about it. Cosine of 90 degrees evaluates to what? It evaluates to 0. And 0 times anything is just 0. So essentially, all of this would cancel out. So then you would be left with the Pythagorean theorem. So basically, the Pythagorean theorem could work in this instance right here, or a right triangle. It's a special case of the right triangle. Yeah. So just thought I'd mention that to you guys. So I am going to go ahead and move on. Now, there are two types of triangle congruencies we look at when we're using the law of cosines to solve oblique triangles. We're looking at SAS, if you guys recall from geometry. That is side, angle, side. As in, if you're given two sides and the included angle, you can use the law of cosine to go ahead and calculate the length of one of the missing sides, okay? So guys, the first step would be to go ahead and use the law of cosine to find the opposite side, the opposite given the angle, okay? So once again, you're going to use the law of cosines to find, that's step one, to find the side, that missing side. Remember, you have two sides already, so you're missing one side. So now your job is to figure out that missing side. So you're going to use the law of cosine to find the side opposite whatever that given angle is. Opposite the given angle. Now, once you find that side opposite the given angle, you're pretty much done with the law of cosine. So now step number 2 is to find the missing angles, okay? Which angle do you want to start with? you want to use this time the law of sine to find the angle opposite the shorter side. And notice I'm not putting a letter to this because you have to figure out which angle is opposite the shorter side. And now guys, look at this. We're using the law of sine to find the angle opposite the shorter side, okay? So that's step number 2. And of course, the third step, because you're missing 2 angles, you are given 2 sides and an angle, so you got to find the first side. That's step 1. Then you got to find the second angle. In this case, the second angle is going to be the smaller one out of the 2 missing angles, okay? And the smaller one is directly opposite the shorter side. And so the last step is to go ahead and find the third angle. And to find that third angle, you're going to use the fact that the sum of the 3 angles of a triangle adds up to 180, okay? So you're going to use the 2 angles, the ones that you've already found, to find the third angle by subtracting, and I'm going to abbreviate here, subtracting from 180. So you take those 2 angles and you go ahead and subtract them from 180 degrees, guys. And so just like that, you would be able to solve that oblique triangle, okay? So essentially, guys, on the first step, use the law of cosine. On the second step, use the law of sine, which we've already discussed. By the way, just in case I need to mention it, so I'm just going to go ahead and give you a review of the law of sine. The law of sine says sine A over B is directly proportional to sine B over side B, and directly proportional to sine C over side C. So that's the law of sine you want to use for step number 2. And step number 3, obviously, it's common sense, guys. All you have to do is take 180, subtract those 2 angles that you already have, the given one and the one that you found in step 2, okay? So this is how you go ahead and solve the oblique triangles involving side, angle, side. So if you're given 2 sides and the included angle. Now, on the other hand, if you're given 3 sides with no angles, okay? So to solve this, you're going to have to find all 3 angles. So here comes step number 1. Now, step number 1, again, you're going to use the law of cosine to find the angle opposite the longest side. Notice I'm saying the longest side, okay? And so you're basically looking for the largest angle. So you're finding the angle opposite the longest side. So basically that's the largest angle out of the 3. Okay, so that's step 1. Now, step number 2, you want to go ahead and this time, just like with the previous problem, you're going to use the law of sine to find either, it doesn't matter which one, of the 2 remaining angles. It doesn't matter which one in this case, guys. It really doesn't matter. And then, of course, last but not least, you're going to find the third angle using, let me see, I'm trying to squeeze everything in here. Find the third angle by subtracting the 2 angles from 180. 2 angles from 180. Okay, I got it in here, guys. I got it squeezed in here. So guys, this makes a whole lot of sense. Essentially, you're given three sides. What are you missing of the triangle? The three angles, okay? So how do you find the three angles of the triangle? So number one, use the law of cosine to find the angle opposite the longest side. And then number two, once you figured out the first angle, you could go ahead and use the law of sine to find the second angle. And once you find the second angle, you can now use the fact that 180 is the sum of the three angles of the triangle. So you take 180, you subtract the two given angles, and then you'll be done. So now, guys, what I would like to do is to go through a couple of examples, and then I will go ahead and stop the recording, okay? So let me go ahead and clear this out. And here comes the first example, guys. And for this one, okay, let me go ahead and sketch it out for you. Triangle ABC, not drawn to scale, okay? So this would be side B, side A, and side C right there, okay? Now, angle A is 60 degrees, right here. That's angle A. And they give you side B is 20, okay? So let me go ahead and erase this part right here. I'm just gonna put the 20 right there, and this part right here, I'm gonna erase that. Okay, so let me go ahead and write the information on here. That's 20. And then side C is 30 units long, okay? So guys, obviously, they give us this angle that is included between the two given sides. So our first step would be to go ahead and find the value of A. So since we're looking for A, we're going to go to the formula. A squared is equal to B squared plus C squared minus 2 times B times C times cosine of A. So we're going to substitute everything in there. Remember, we're looking for A. Now, let me just say this, guys. One of the things I like to do is to do a deviated form of this formula, because eventually you're looking for A. You're not looking for A squared. You're looking for A. So essentially, A is going to equal to B squared plus C squared, okay, minus 2 times B times C, and then times the cosine of A. So what I'm doing here is doing some of the work ahead of time. And now all I have to do is go in and plug in the values and drop it in my calculator. So B, side B is 20. So we're going to square that. Side C is 30. So we're going to square that. And then minus 2 times side B, which is 20, multiplied by side C, which is 30, multiplied by cosine of angle A, which is 60 degrees, okay? So now I'm just gonna go ahead and grab my calculator, throw this on the calculator, and let the calculator figure it out. So guys, essentially, this part under the square root is going to come out to be 700. You take the square root of 700, and this becomes 26.5. So which means the length of side A is 26.5. So now we have the lengths of all three sides. So now we got to go back and figure out one of the angle measures, because remember, we have two angles that we don't know the value of. So now we got to go back and find them. So that the big question is, how do we calculate the measure of the missing angles? And which one do we do first? Does it matter? In this instance, it matters. Okay, so in this instance right here, guys, the one that we're going to find next is the angle that is opposite the shortest side. And the shortest side is right here. The angle that's opposite the shortest side is angle B. So we're going to be looking for angle B. Now we're going to go to the law of sine in order to calculate the value of angle B. So we're going to do sine of angle A over the length of side A is equal to sine of angle B over the length of side B. So when we set it up, this is what we're going to end up with. We're going to end up with sine of 60 degrees over 26.5 is equal to sine of B, because we don't know what it is, over 20. We're going to next, this is a proportion. To solve a proportion, you're going to cross multiply, okay? So what you end up with is 20 times sine of 60 is equal to 26.5 times sine of B. Now, in order to solve this, we're going to divide both sides by 26.5. So we're going to end up with 20 times sine of 60 over 26.5. And this will equal out to sine of B. Now, you want to grab your calculator, plug this into your calculator, guys. Plug it into your calculator. And so when you plug this into your calculator, it's going to come out to be approximately, this part right here is going to come out to be approximately 0.6547. 0.6547, and that's going to equal to sine B. So in order to finalize this, because you're looking for an angle measure, you're going to do the inverse of sine of 0.6547, and this will lead you to a measure of 41 degrees. Try it on your calculators, guys, okay? So this means angle B is 41 degrees. And so now that you know angle B is 41 degrees, you can now figure out the value or the measure of angle C. So the measure of angle C will be 180 minus the other two angles, which are 6 degrees and the 41 degrees. So this will leave you with what? Let's see here. 79 degrees. Okay, guys? 79 degrees. And just like that, we are done. As I promised, I was going to do 2 examples with you guys. This is the first example using the Sss congruency, where you're given 2 sides and the included angle, and you got to find the missing side and the 2 missing angles, okay? So let's go ahead and do one more example, and this time we're going to use the SSS, okay? Yeah, SSS. Now, for the SSS triangle congruency, we're going to look at this triangle right here, and triangle is not drawn to scale. Triangle ABC, okay? So it says A is 6, the length of side B is 9, and the length of side C is 4, okay? So obviously, side C is the shortest, the longest is side B. And so guys, when you are doing the SSS congruency, the first step is to use the law of cosine to find the angle opposite the longest side. So the angle opposite the longest side would be angle B. So we're going to use the law of cosine to figure out angle B first. So the formula we're going to use is B squared is equal to A squared plus C squared minus 2 times A times C times cosine of B, okay? And then you want to go ahead and take the square root. I like doing this, you know, taking the square root so I can go directly into the formula and just find that value, guys, okay? So A squared plus C squared minus 2 times A times C times the cosine of B. And so that's how you're going to calculate the value of B. So now we're going to plug in those values. The A value, the number, the length of side A is 6. The length of side C is 4. So 2 times 6 times 4, and then times cosine of angle B, which we don't know. Okay. By the way, I think I may have gotten ahead of myself. Ooh, I think I did, guys. Okay. So hold up a second here. I got a little bit ahead of myself here, guys. Okay, let me go back a little bit. I need to erase all of this because I forgot Shazam. I'm looking for, okay, the angle measure. I'm not looking for the side. I'm looking for the angle measure. So I plugged in the wrong values, guys, okay? So let's try this one more time. Side B is 9. Side A is 6. Side C, the length of side C is 4. Okay, so you see where I made the mistake, guys? I plug in the values in the wrong spot. Basically, I didn't plug in the value for B. Okay, so A, the length of side A is 6. The length of side C is 4. And then all of this is going to be cosine of B. Now, we're going to grab our calculator, plug all of this into the calculator, guys, so we can figure this out, okay? So we got 81 is equal to 36 plus 16 minus 2 times 6, which is 12. 12 times 4, that's going to give us 48 cosine B. And then you add these two together, so that's 81 is equal to 52 minus 48 cosine B. And then you want to subtract the 52 from both sides. So this turns out to be, what's 81 minus 52? Shazam. I'm having a little block here, guys. You need to, let me see here. 81 minus 52, that's going to be 29, guys, 29. Okay, now I'm doing it the long way. You don't have to do it with all the steps here. You can do it in just a couple of steps, but I'm going through it the long way, guys, okay? So all of this cancels out, leaving you with cosine B is equal to a negative 29 over 48. Now, you're looking for the inverse of this, guys, because you're looking for angle B. So to calculate the value of angle B, you're going to have to do the inverse of cosine of negative 29 over 48. So you grab your calculator, throw this into a calculator, guys, and this one comes out to approximately 53 degrees. 53 degrees, okay? So that's measure of angle B, 53 degrees. So guys, once you find the measure of one of these angles, you're done with the law of cosine. So now you can move on to the law of sine to calculate the value of one of the other angles. Does it matter which one? No. In this situation, it really doesn't matter which one you figure out first. You can either figure out angle A or you can figure out angle C. It does not matter, okay, guys? So in the case of this one right here, I think I'm going to figure out angle A next. So to figure out angle A, I'm going to use the law of sine. So I'm going to do sine A is over the length of side A. That's going to equal to sine B over the length of side B. So I'm going to fill it in. Sine A, I don't know what the value of A is. The length, though, I do know what it is. It's 6. And then sine of 53 degrees over 9. So we're going to cross multiply. So when we cross multiply, we get 9 times sine A is equal to 6 times sine of 53. And to solve this out, you divide both sides by 9. So you're going to grab your calculator and throw this into the calculator, guys. And when you do the calculation 6 times sine of 53 degrees divided by 9, this is going to come out to be approximately, okay, this is just an approximation, 0.5324. Now, once again, what are we looking for? We're looking for an angle measure. So to figure out the angle measure, we're going to go ahead and do the inverse of sine of 0.5324. And this comes out to 32. 32. And that's it, guys, okay? So once you figure out measure of angle A is 32, guys, you have 2 angles of a triangle. It's very easy to find the third angle. How do you find the third angle? You take 180 and you subtract the 2 given angles. Subtract the 53, subtract the 32, and I'll give you a missing angle. And in this case, the missing angle is going to be what? 21 degrees. Yeah. All right. No, that's not going to be 21 degrees. That's not going to. Let me see, 75. And if we subtract here 75 from 180, that's going to be 105. Okay. Well, that's not making any sense. What did I leave out here? Oh, Shazam. I forgot I had a negative angle measure. Uh-oh. Okay, guys, you see how this is 105 and it's directly across from the shortest side? That would not make any sense. You know what I forgot? I forgot that when we did this problem originally, okay, I'm gonna go back just slightly, okay? When we did this problem originally for the 53-degree angle, guys, we found that for a negative angle measure, it was a negative value, okay? So in order to find the angle B, you had to go ahead and subtract 180 minus the 53, Shazam, and this would have given you 127 instead. So I'm just backtracking a little bit because I realized, wait a minute, this is not making any sense, okay? So I'm just gonna go back over here and fix this, guys. So that's 127 over here. So if that's 127, guys, so all my B values, I'm gonna have to change them over here. So over here, this is gonna become 127 right there. Okay, I'm using a different color here because I'm making some changes. That's gonna be 127 right here, okay? So now I'm gonna go ahead and carry out with the rest of the problem. Now, since this is 127, let me see here. Sine of this, 6 times sine of 127 over 9, it is going to come out to be this value, okay? So now that we have this, the 0.5324, and we take its inverse, it does become a measure of 32. So angle A is still 32. The only problem is, guys, now for angle C, obviously, it's going to be a smaller value than the 32, okay? So we take 180, and we're going to subtract the 127, subtract the 32, and this will leave us with 21 degrees. There we go, 21 degrees. Ah, that looks so much better, guys. So much better, okay? So essentially, guys, when you're given 3 sides of an oblique triangle, you got to go figure out the angle measures. How do you figure out the angle measures? Number 1, you want to go ahead and figure out the measure of the largest angle. So find the angle that is directly across from the longest side. That's the one you target first. To find it, how do you find it? Use the law of cosine. So that's step 1. Step 2, now be careful with those negative angles. You notice I made an error there because of that negative angle, okay? So side 2, guys, listen. The second step is to go ahead and find one of the other 2 missing angles. Does it matter which one you find next? It doesn't matter. Just use the law of sine to find the measure of one of the other 2 missing angles. And once you find 2 missing angles, guys, that's easy to find the 3rd missing angle. Just take 180 and minus those 2 angles. So, guys, that's it for the law of cosine. Until next time, bye, everybody. We'll do some additional examples in class.